Welcome back, folks. And this would be the last video that I have for you in the alkyne series. And the first and last one in the alkyne series is, let's take the same compound that we've been working with. So CH3, CH2, C triple bond CH, right? Now this, when it reacts with a whole series of reagents, again, it's sodium sodium amine, NH3, let's keep it like this, okay, for now, and then I can switch over to a more generic of this third reagent that I just wrote. Okay, now the reason I gave you that short introduction about nucleophile is this sodium amine derivative it's a weak base, but nevertheless it's a base. So sodium is a metal, so it's positive. Anything nitrogen containing compounds is typically negative. Okay, so it's NH2 minus. So this is really what we focus on, and this is a nucleophile. Why? Because it's got a negative charge, right? So what does that do? Well, I'm going to walk you through the mechanism and then summarize it with one more generic compound. What would this be if it's not CH3 but something else? All right, so let's get this moving. So CH3, CH2, C triple bond C. I'm going to write this as this way instead of just, so that you can see the bond movement. Okay. So the NH2 minus, as always, going to pay attention to the bonds, the way I move it, and the charge displacement. Okay, that's very important. When you watch a video like this one, you got to pay attention to the detail on where things go and how things work. Okay. NH2 minus is a nucleophile, so it obviously lacks an electrophile, and hydrogen, as I've said already in my first video, is an electrophile. So it grabs it. What it does is, in the process, transfer this bond to the carbon. And I think when we learned how to move bonds back and forth, I did tell you that when a bond comes back to an element, it gets a negative charge. When a bond completely moves away from an element, that element gets a positive charge. In this case, the bond is coming back to the carbon, and whatever negative is lost here must be given back. There was one negative, so that one negative must transfer here. Okay. And again, none of this is black magic or some kind of abstract thing. This is all real. So, so the negative charge comes over here. Now, what is this going to do? Well, anything with a positive or negative is unstable. It would like to go into a form where the positive or the negative is no longer present. Okay. Now, this is all reaction medium. Okay. This is a reaction medium for this. This is a reaction medium for this. So this now reacts with CH3Br. Okay. So this negative charge comes and attacks this carbon, and then the Br comes out. Again, why does the Br have to come out? First, Br is a good leaving group. Second, if I didn't do this, then this carbon would have 5 bonds, and that's not acceptable, right? So what happens then? All you have to do is CH3, CH2, C triple bond C, connect, because the negative is used as a bond to connect this carbon and this carbon right here. So basically it attaches itself to the CH3 plus Br minus. And keep in mind, the Br minus may not be floating by itself, so it reacts with the sodium that's there, and you make NaBr. Now, this is not something you have to really do, but if you're wondering, hey, what happens to the sodium plus that you just left out? Well, it's called a spectator ion. So is the Br minus. So it ends up making sodium bromide. So the two spectator ions, positive and negative, combine to make sodium bromide. Now, I did mention that what if this is not a CH3, but could be anything? So in general, this is how, if you read a textbook, more likely this is how you would see it. So this now reacts with the same NaNH2, NH3, say RBr. This R could be anything but hydrogen. Okay, R is not equal to hydrogen. That's the only thing. But otherwise, R could be anything, and then you've got your THF. So same deal here. So your product would be CH3, CH2, C, triple bond C, R. What has happened is exactly the same as I've shown above. You've made a minus here, and the minus reacts with the R, the Br comes out, and you make. So this is more of a generic product. The R could be anything to start with, but a hydrogen, okay? And that all I have for the alkyne series of videos. So the next topic we're going to learn would be probably something more refreshing to some of you, because it does not involve a reaction. It's about predicting something is aromatic or not, okay? And I think that will be a change, and probably in a way more refreshing to some of you. And actually, personally, I like that concept, because again, it's fun playing with a molecule, trying to figure out if it's aromatic or not. And so if you have enjoyed figuring out whether a compound is alkane, alkene, or alkyne, and I think this is pretty much along those lines, and I think you would like it, probably will not give you any hard times completing a question that's written on it. Anyways, I'll see you back another video on aromaticity and figuring out whether a molecule is aromatic or not. So stay tuned for more videos. Bye-bye.